life. The Indonesian archipelago comprises some 17,500 islands. Home to some of the world's most unique wildlife, the Indonesian archipelago comprises some 17,000. Home to some of the world's most unique wildlife, the Indonesian archipelago comprises some 17,500 islands. Indonesia takes up less than 1.5% of the world's land, but is in fact home to more than 15% of the wildlife found on Earth. It sits between the continents of Asia and Australia, which gives the region an incredibly diverse range of animals. In the western end of the country, you will typically find species that are also commonly found in Asia, but as you head east, you'll soon run into species that are more commonly found in Australia. Before we begin, help us out by clicking the like button. Now, here are 10 unique animals only found in Indonesia. Number 10. Javan gibbon. Also known as the silvery gibbon, the Javan gibbon is a primate that is endemic to the Indonesian island of Java, where it can be found in rainforests with an altitude of up to 8,000 feet. They are bluish-gray in color and have a dark gray, sometimes black cap. They have long, curved fingers and, when compared to their hind limbs, have unusually long forelimbs. They weigh around 8 kilograms and can climb trees incredibly well. This rare species has a diet that consists of fruit, leaves, and flowers, and like every other gibbon species, they don't have a tail. On average, the females give birth once every 3 years. The young live with their family for
Halo, Assalamualaikum, Mas.
Halo, Waalaikumsalam, Mas.
Oh, ini komite yang ISC 2021 siapa nih, Mas?
Saya semua ini, Mas, pegang 3 device.
Gelo.
Makanya ini sedikit lumayan kewalahan.
Nanti sore lah saya balik lah, Mas. Nggak apa-apa lah.
Enggak apa-apa kalau memang inian mah jangan. Kalau masih sakit itu nggak usah.
Ya, lihat kondisi nanti deh.
Ini
Kirain ada Mas Win di sana enggak ya?
nggak ada siapa-siapa.
Sebenarnya bisa nggak sih online semua? Atau emang ini? Yang penting koordinasi lancar gitu bisa nggak sih?
Apa kalau online sambil ini ya bisa
Iya.
kalau megang job desk-nya masing-masing sih.
Yang ribut sih besok ya. Soalnya saya ditempatin di moderator, jadi nggak bisa ngapa-ngapain deh tuh.
Nah iya kalau masuk ke moderator ya jangan. Ini aja yang tim teknis aja siapa yang sekiranya nggak masuk moderator ya minta bantuan paling gitu.
Iya. Dibahas di ini deh. Di grup deh.
Iya, ini cukup kewalahan soalnya kalau jadi kayak gini langsung ngatur semuanya.
Udah makan belum? Masih, Mas?
Belum. Saya takut kalau ditinggal ini nanti nanti aja lah. Kalau udah mulai
Aduh.
speakernya.
Oh, kalau udah kuliah umum ya.
Iya.
Bentar, Mas.
Ini mau kita buka kapan nih, Mas?
Udah buka aja, Mas.
Oke.
Sambil setel musik aja.
Assalamualaikum, Sir Arifin. Good morning.
Waalaikumsalam, Mas Bayu.
morning, Sir Mursyid. Assalamualaikum.
Good morning, sir. Good morning, sir.
Good morning.
Good morning, sir. Yes, good morning, sir.
Waalaikumsalam warahmatullahi.
Waalaikumsalam warahmatullahi.
Hai pemain satu, siap hadapi tantangan ini? Masuk.
Hello, good morning. Can you hear me clearly?
Morning, ma'am. Okay.
Good afternoon, Miss.
I
Hi.
hear your voice, ma'am.
Okay, good to know. Thank you.
You're welcome, ma'am.
Um, okay, let's start. Good morning, everyone, ladies and gentlemen. Thank you for coming for this event. Welcome to International Student Conference or ISC 2021. And my name is Windy Alzahra, and I will be your host for this event. Thank you very much for being here with us. But before we start, could you please turn on your camera so we can see some nice faces from different countries during this event, lecture, and also for tomorrow? That will be very appreciated. Okay, I see some faces now. Yeah, that will be very great if you can turn on your camera so we can see you. Okay, great. Thank you very much. And yeah, for your informations, ISC is part of the summer course program, which has been organized successfully by the Department of Animal Production and Technology from 12 to 23 of July 2021. And as part of the program, we have received plenty of abstracts, posters, and photographs from summer course participants, which will be displayed today and tomorrow. And we also will discuss about the essay actually tomorrow. So we really encourage you to stay with us for this today's event. And for today, there will be an opening ceremony in which there will be a guest lecturer, a virtual expo. And then in virtual expo, there will be posters and photographs will be displayed, and you would have a chance to select your favorite posters and photographs. And for tomorrow, there will be presentations from selected essays. Okay, without further ado, I would like to invite first the ISC coordinator, Professor Asep Gunawan, to deliver a brief speech. Pak Asep, are you there?
Yes, Ibu Windy.
Yes.
Can you hear my voice clearly?
Yes, perfect. Yes, Pak Asep, the time is yours.
Okay, thank you. Bismillahirrahmanirrahim. The Honorable Dean, Faculty of Animal Science, Dr. Idat Galih Permana, distinguished lecture for today, Professor Dr. Misiano Hashimoto from Singapore University of Technology and Design University, Vice Dean for Academic and Student Affairs, Professor Irma Isnafi Arif, Head of Department Animal Production and Technology, and also Secretary, Dr. Tuti Suryati and Dr. Jakaria, guest lecture from different university that already been participates since this is the whole sequence from summer course program. We would like to thanks, and also lecture of Department Animal Production and Technology, Professor, Head of Division, Associate Professor, and also Assistant Professor, organizing committee and participant of International Student Conference, and also presenter who already selected paper for the conference, and also all students from Department Animal Production and Technology who attend from to this event. Good evening. First of all, it's my great pleasure to welcome you all to the second International Student Conference of DAPT 2000 to 2001. Thank you very much for being a part and participating in this event, especially for our leaders, in faculty, and also to guest lecture today, Professor Misiano Hashimoto. Thank you very much. And also participant from IPB, other university in Indonesia and also from a foreign country. This event of International Student Conference, or we call ESC, will be held from today, 2nd August, until tomorrow, 3rd of August 2001. The program, like that already mentioned by MC, consists of plenary session, lecture from a guest lecture, exposition that we provide and display, player, photography, poster session related with local animal production, local wisdom, culture, and also, of course, yeah, related with the new normal foundation. And also the interesting event is parallel session for tomorrow. This ESC 2021 is considered an excellent platform for students to get nurture scientific and academic skill at the international level, as well as to achieve their agile soft skill. I also believe that the sharing knowledge from this event can increase the collaboration among Indonesian university and also international collaboration with foreign country. We received that ESC 2021 has successfully attracted more than 131 papers, from 6 countries: Malaysia, Thailand, Taiwan, Philippines, Bangladesh, and also, of course, from Indonesia. We indicated this event very interesting and attractive to create scientific atmosphere work from local and also international basis. So on behalf of the organizing committee, I would like to express my sincere appreciation thanks to IPB, with its representative by Directorate of International Program, and also, of course, our leader, Dean Faculty of Animal Science, Head of Department, Animal Production and Technology, and also all together organizing committee who make a success this event. My recognition and gratitude also being for a great contribution to the guest lecture who accepting and willingness to accept our invitation to share knowledge in this guest lecture event. So to participants who will be presented your paper tomorrow, we would like to say congratulations, good luck and success. And also, of course, to all students who join on this event today until tomorrow, may bring fresh the idea and also enhance collaboration for the future success toward new normal challenge and opportunity, global interconnectivity for animal production. So big apologize for any inconvenience during the International Student Conference. Wish you all having a good time and also fruitful discussion this conference. Thank you. Assalamualaikum warahmatullahi wabarakatuh. I will be back to Bu Windy. Thank you.
Yeah, thank you very much, Pak Asep, for your nice word. And next, I would like to invite the head of Department of Animal Production and Technology, Ibu Dr. Tuti Suryati. Ibu, the floor is yours.
Okay, Bu Windy, thank you. Good afternoon, everyone. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for Dean of Animal Science, Faculty of Animal Science, Dr. Idat Galih Permana, and Vice Dean for Academic and Student Affairs, Professor Dr. Irma Isnavia Ari. guest lecturers and all participants, and also for our lecturer of Department of Animal Production and Technology. Thank you for your join in this event, and I hope this event can success and also make some experience for some students to develop your experience and how to express presentation in in formal competition. So that's a point you can get in this event. And then I think this is event for our other students from study program technology, animal product technology and animal production technology also. So this event can be claimed as seminars presency. Seminar present. That's, I think. Thank you for your comings. I think it's all. Thank you, Bu Windy. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Ibu Tuti. And now I would like to invite the Dean of Faculty of Animal Science, Bapak Dr. Idat Gali Permana. Bapak, the time, and also to officially open this ISC. Bapak, the time is yours.
Okay, thank you, Windy. Distinguished guest lecturer, Professor Dr. Michiano Hashimoto from Singapore University of Technology and Design, Vice Dean for Academic and Student Affairs, Faculty of Animal Science, IPB University, Professor Irma Isnafi Arif, Head of Department of Animal Production and Technology, Dr. Tuti Suryati, and the Coordinator of International Student Conference, Professor Asep Gunawan, all lecturers from Department of Animal Production and Technology, and all participants and students who are participating in this student conference. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. On behalf of the Faculty of Animal Science, IPB University, I would like to welcome you all of the participants to the second International Student Conference 2021, which is organized by Department of Animal Production and Technology, Faculty of Animal Science, IPB University. I appreciate the Department of Animal Production and Technology and the committee of the International Conference for having this program. As you know that currently we are still in the pandemic condition, so this conference will be conducted online. This year, the Faculty of Animal Science is offering two summer course. First is online international seminar conducted by Department of Animal Production and Technology. Is already started since 2 weeks ago with the topic the new normal challenge and opportunity, global interconnectivity in animal production. And the second is the international course conducted by Department of Nutrition and Feed Technology, the topic of exotic tropical animal nutrition and feed technology. This summer course is open in the morning. This international conference is a series of the summer course activity held in the both department. As the head of department mentioned, that this event can be also claimed as the course in the curriculum of the Faculty of Animal Science. As reported by the organizing committee, this student international conference is attended by more than 100, I think more than 150 participants from 6 countries. Yeah. the theme of the International Student Conference is very interesting and relevant to discuss, considering that we are currently still in the situation of the COVID-19 pandemic. So the pandemic has changed almost all of the sector, and the impact of the COVID-19 pandemic has also been affected to the livestock production. Some of them require new adjustment and adaptation to support fulfillment of demand of the livestock production. In International Student Conference, students are also expected to be able to present the result of their research and studies. So the students from various countries can learn from each other and share knowledge and experience. And in this conference, because also the students not only present the result of their studies, but there are also student competition, as the head of the department mentioned before, in photographies, poster, and the essay related to the animal production. This student competition is good for good activity in increasing of the competitive spirit of the student in field of the animal production. Finally, to all the committee members of the Department of Animal Production and Technology, I would like to express my appreciation and gratitude for your full dedication in organizing this conference. And for all participants, I wish you all success and having good experience. And I would like to officially open the International Student Conference 2021, conducting by Department of Animal Production and Technology. Bismillahirrahmanirrahim. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Pak Idat, for your nice word. And for now, we actually, as the committee, we have a nice video and a very interesting video in which we will show you the only livestock or animals can be found only in Indonesia. So because we see so many participants coming from abroad, so we also want to show you the uniqueness of Indonesia. So Mas Arifin, could you help me to share the video? Yes.
Home to some of the world's most unique wildlife, the Indonesian archipelago comprises some 17,500 islands. Indonesia takes up less than 1.5% of the world's land, but is in fact home to more than 15% of the wildlife found on Earth. It sits between the continents of Asia and Australia, which gives the region an incredibly diverse range of animals. In the western end of the country, you will typically find species that are also commonly found in Asia, but as you head east, you'll soon run into species that are more commonly found in Australia. Before we begin, help us out by clicking the like button. Now, here are 10 unique animals only found in Indonesia. Number 10, Javan gibbon. Also known as the silvery gibbon, the Javan gibbon is a primate that is endemic to the Indonesian island of Java, where it can be found in rainforests with an altitude of up to 8,000 feet. They are bluish-gray in color and have a dark gray, sometimes black cap. They have long, curved fingers and, when compared to their hind limbs, have unusually long forelimbs. They weigh around 8 kilograms and can climb trees incredibly well. This rare species has a diet that consists of fruit, leaves, and flowers, and like every other gibbon species, they don't have a tail. On average, the females give birth once every 3 years. The young live with their family for around 18 months, until they're fully mature, usually around 9 to 10 years old. This relatively slow spawning habit has led to a pretty low population for the rare species, with an estimated 2,500 Javan gibbons left. Since 2008, the species has been classified as endangered by the IUCN. Number 9. Wilson's Bird of Paradise. In 1863, German zoologist Heinrich Agathon Bernstein discovered that the Wilson's Bird of Paradise considers Waigeo Island their home. This rare animal is endemic to Indonesia and is distributed across the hill and lowland rainforests of Batanta and Waigeo Islands off West Papua. These incredible birds are rather small, only reaching a length of up to 16 centimeters. They weigh around 60 grams, and males are usually red and black in color, with a yellow mantle on their necks. They have light green mouths, rich blue feet, and have 2 curved violet tail feathers. Their heads are naked blue and have an incredible cross pattern on them. Females are brown and have a bare blue crown. The crown of the bird's head is so bright that it's even visible at night. The species is classified as near threatened by the IUCN due to many factors such as habitat loss and human exploitation. Number 8. Turquoise monitor. This incredible-looking lizard is found on the Halmahera and Maluku Islands of Indonesia. The turquoise monitor lizard can be found in a black to brown and a gray to brown color, detailed with a vibrant turquoise-colored pattern. Their underside is usually light yellowish to turquoise in color, sometimes accompanied by a black pattern. The turquoise monitor lizard can grow up to about 110 centimeters in total length and has a diet that consists mainly of crustaceans, scorpions, grasshoppers, and even frogs. Unfortunately, not much else is known about this amazing lizard because they're incredibly hard to find. Number 7. Bleeding toad. The bleeding toad, sometimes also referred to as the fire toad or Indonesia tree toad, is a species endemic to the West Java island of Indonesia. More specifically, they're found around Mount Gede, Mount Pangandaran, and South Sukabumi. As a mountain-dwelling toad, they live in altitudes of up to 6,000 feet above sea level and are commonly found near small mountain creeks. They're medium-sized toads that have a dark red or purple bodies with sharp red or yellow marbling on their back and legs. They can grow around 30 millimeters in length, with females being larger, growing up to 40 millimeters. When stressed or threatened, the bleeding toad secretes a substance from its skin. This, along with its sharp red detailing, gives the species its name. The female also lays their eggs in slow-moving streams and creeks. Unfortunately, the species is in a drastic decline for unknown reasons, but the eruption of a nearby mountain in 1987 certainly didn't help it. In fact, this species is so rare that it's said that only one bleeding toad was sighted between 1990 and 2003. Number 6. Celebes rainbowfish. Celebes rainbowfish are endemic to Sulawesi, which was formerly known as Celebes in the country of Indonesia. More specifically, these rare fish are only found near the town of Maros. They dwell in bodies of water like streams and estuaries that have fresh to mildly salty water and live in areas with dense vegetation. They spend most of their days hiding in the leaves of nearby plants, where they can easily find most of their food, which consists of insects, shrimps, worms, or debris left by other creatures. As for their appearance, the Celebes rainbowfish are among the smallest in the rainbowfish family. Males of this rare species can grow up to 8 centimeters, with females being a little smaller, growing up to a length of 7 centimeters. Males have yellow and blue colorations on their fins and bodies, and their dorsal and ventral fins are black and elongated. This is quite different from the females, which are typically found to be less colorful. Their population has drastically declined due to many factors, such as pollution and the local ornamental fish business. We're now halfway through our video. If you're still with us, comment the Indonesian flag emoji down below. Number 5. Wallace's golden birdwing. What an incredible sight to behold! The Wallace's golden birdwing is a species of butterfly endemic to Indonesia and can be found in the northern region of Maluku. It gets its name from Alfred Russel Wallace, who described the species all the way back in 1859. In his book, The Malay Archipelago, he recounts that the bird's beauty and brilliancy were indescribable. He even went on to say that he almost fainted when the rare butterfly opened and fluttered its wings upon being released. And just like Wallace, we think this butterfly is seriously indescribable. Number 4. Bornean flat-headed frog. It's the first and only known lungless frog. The Bornean flat-headed frog breathes entirely through its skin. This species is incredibly rare and had previously only been collected twice, and they were 20 years apart. It was later rediscovered in 2008, and since then plenty more sightings were recorded in the areas it's resided in. It's only one of 2 in its genus, the other being the Philippine flat-headed frog found in the Philippines. These 2 species of frogs are quite old, having evolved from amphibians 65 million years ago. That's around the time the dinosaurs went extinct. They grow up to a length of 3 inches, with females being slightly larger than males. Unfortunately, this species is currently threatened by habitat destruction, mostly because of illegal gold mining in the local area. Number 3. Sumatran orangutan. This species of orangutan is one of 3 found in the northern areas of Sumatra, the other being the Bornean orangutan and the Tapanuli orangutan. This unique animal hangs out in the trees of tropical rainforests and almost never travels on the ground. They seem to have a tightly knit social circle and prefer to eat together. Males grow to around 5.5 feet tall and weigh around 200 pounds. Females are typically smaller. They average only around 3 feet tall and weigh less than 100 pounds. They used to be distributed over the entire island of Sumatra and sometimes further down south into Java, but are now restricted to just the northern part of the island. Aside from habitat loss, these orangutans are also sometimes traded illegally as pets, leading to its assessment as being critically endangered. Number 2. Javan hawk eagle. The national bird of Indonesia, the Javan hawk eagle, is considered the symbol of all the country's rare species. It's only found on the island of Java and is one of the world's most endangered raptors. Bad news doesn't end there, however, as the species is also not very well known, mostly due to its incredible rarity. From what we do know, the Javan hawk eagle stands at less than 25 inches, with its white-tipped crest giving it an extra boost in the height department. The body of these raptors is caramel brown in color, but their wings are much darker and more intricately patterned. Sexes of this species are a little hard to tell apart, as they look quite similar to each other. If you're feeling lucky, the Javan hawk eagle is typically found in humid tropical forests found in East Java, or you can take the easy route and see them in captivity, as some zoos in the local area sometimes have them around. You are nearly at the end of our video. We're on a mission to find and document all of Earth's wildlife. Make sure you're subscribed, that way you'll always be notified of our latest videos. Number 1. Komodo dragon. Perhaps the most well-known animal on this list, the Komodo dragon is endemic to Indonesia, more specifically to the island of Komodo, and some other islands with names that, for your sake, we won't try and pronounce. They usually live in a wide range of habitats found on the islands, but mainly in the tropical savanna forests. True to being unique, these rare creatures are the largest living lizards in the world. They are apex predators, dominating the other species in its areas. Although they might seem heavier, these lizards typically weigh around 150 pounds, though there have been some found to weigh as much as 350 pounds. The Komodo dragon has a venomous bite that's very lethal, have glands in their mouths that secrete toxic proteins when they bite. Sexes of this species are quite difficult to figure out, though males do tend to be a little larger. It still remains a challenge for many researchers to differentiate them. Hey, thanks for watching. Want to suggest a video or have something to say? Let us know in the comments section below. Check out our wildlife playlist for more videos like this one.
Thank you very much. That was very interesting that you can see now Indonesia is really rich in the biodiversity of the animals from the west to the east, and then there's also so many very unique creatures. Such kind of the Komodo, it's really unique and very interesting, of course. And I would like to say hello to Professor Hashimoto. Are you here there with us already?
Yes, I am here.
Yeah, okay, nice, thank you. And I also want to say some hello to our colleagues. We also see some colleagues from animal production from the department. Thank you very much for being here. And before we continue for the lecture of Professor Hashimoto, we would like to ask all participants to turn on your camera because we will have photo sessions together. So could you please turn on your camera so we can have a documentations of this nice event. So yeah, and then Mas Arifin or Mas Jimas, could you help us to take a picture together?
Okay, Mbak Windy, thank you.
Yep.
Hey everyone, please turn on your camera and we'll take a picture together for the flat one. 1, 2, 3. Wait a minute. Okay. For slide 2. 1, 2, 3. And slide 3. 1, 2, 3. And slide 4. 1, 2, 3. And slide 5. 1, 2, 3. Next slide. 1, 2, 3. The 7. 1, 2, 3. And the last part, 1, 2, 3. Thank you, Mbak Windy.
Yeah, thank you very much. That was amazing. We have almost 200 participants for this event, which is very great, of course. And for the next, we are moving for the guest lecture which will be delivered by Professor Hashimoto from Singapore University of Technology and Design. And for this lecture, I invite Dr. Cahyo Budiman as moderator. Pak Cahyo, are you there?
Okay, yes, I'm here.
Yes, perfect. So Pak Cahyo, the time is yours. Thank you.
Okay, thank you, Bu Windy. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon, everyone. I think most of all the participants are the participant from the summer course program last week, if I'm not mistaken. So welcome back to the sister program of the summer course program for the on the International Student Conference 2021. I'm glad to have the speaker today with us, Professor Michinao Hashimoto. Professor Hashimoto is supposedly be one of the lecturer in the summer course program, but due to the tight schedule, he was not able to join with us during the summer course program. However, we are very lucky to have him, still having him today for delivering the lecture on his research on the 3D printing of for the milk products. Okay, before we start the talk, I would like to briefly introduce the speaker. We have Dr. Michinao Hashimoto. Now is Associate Professor in Singapore University of Technology Design. I hope the picture is correct, Rolf. I took it from the university website. All right. Okay, so the email and contact and so on are here for those who are interested in contacting him for further discussions on the topic. His research area mostly on biomedical engineering, and then in Singapore University of Technology and Design, he belongs to the research cluster of engineering product development. Okay, next slide, please. Okay, Professor Hashimoto has his BSc in biochemistry and biophysics in Oregon State University in the United States in 2003. Also in chemistry at the same university, also at the same years. Okay, two degrees, yeah, 2 undergraduate degrees. And then pursuing his master degree in chemistry in Harvard University, wonderful, in 2005, and then his PhD also at the same university under chemical physics program. And then after finishing his study, Professor Hashimoto became a graduate research assistant. I mean, during his study, he was a graduate research assistant in Harvard University from 2004 until 2009. Soon after finishing his PhD, Professor Hashimoto became a postdoctoral associate in Boston Children's School, and then also become a postdoctoral associate in, okay, it's difficult for me to pronounce, Massachusetts Institute, MIT. All right, and then from 2014 until now, he is assistant professor, Singapore University of Technology and Design, and actually he was also promoted as associate professor in the same university. And then move please to next slide. His research interest is mostly in microfluidics, both fundamentals and applications, and he has a lot of ongoing research topics, including multi-phase microfluids, biomaterial formations, drug delivery, and development of medical and diagnostic devices. And then he also interested in how to make the cost to become more efficient for science and technology in making them accessible to broader range of people. Along this line, his research interest is on low-cost device fabrications and their applications in point-of-care settings. So you may wonder what is this field relations with animal science, but recently Prof. Hashimoto and his group published a very interesting paper on how he developed a 3D printing technology on milk products. I hope that, I believe that Prof. Hashimoto will describe more about this in his talk. Okay, let's move to the next slide. So this is some publications that he recently published. You can go through onto his publications later. I think quite productive to produce a scientific paper, and then move. All right, he got also patents on the robust stretchable electronic under US patent applications. And then he got several awards, prestigious award, including Lindau Nobel Laureates meetings under GSPS in 2010. And then in 2010 also he got BOSS Fellowship for Euroscience Open Forum under BOSS Foundations. And then before that, he got a Fisher Lecture Award from Harvard University. From Harvard University also, he got Nanoscale Science Engineering Central Travel Fellowships, Chemical Physics Student Fellowships, and CUE Award Distinctions in Teaching in Harvard University, a very prestigious award. I think by that, I would like to share the stage to Prof. Hashimoto to start the talk. And before the lecture started, I just would like to remind the participants to not forget for fill in the attendance forms, and also to mute your microphone during the talk unless otherwise requested. And whenever you have questions, I prefer you to raise the questions directly to the lecturer. You may text your questions, or you may let us know in the chat room if you have any questions, and then the committee will unmute your microphone to allow you to talk directly. Yeah? So I think let's make these sessions become more interactive. And please also don't hesitate to have, if you have any comments and questions to the lecturer. I believe that Professor Hashimoto will be very happy to hear from you. Okay, Prof, time is yours for your talk. And then, okay, sorry, committee, please turn off your recording, as Professor Hashimoto requested me for not recording the talk due to the confidential data and so on. All right, thank you.
Let me, can you help? I can share the screen.
Sure, sure. You have a share screen button, I think, below your.
Yes, it was prohibited previously. So okay. Do you see the share screen?
Yes, yes, yes. Okay.
So
I can see your slide. Yes.
Okay, this is great. It's a full screen, right?
Yes, it's full screen.
Okay. So good afternoon, everyone. So first of all, thank you very much for the invitation to this student conference. And then I'm really happy that to be a part of this conference. Thanks for the Kyle for introduction. This is very good, the kind of introduction. So my name is Michinao Hashimoto. I'm an associate professor from Singapore University of Technology and Design. And then before this, this was a great movie of Indonesia. I was very impressed. Also, I have only been to Indonesia once, so I really wish to visit once again whenever situation gets better. Today I'm going to talk about this 3D printing of food ink. This is more like to be fair, I think I'm talking to the audience of the Faculty of Animal Science, but this is more like engineering topic. This is using the 3D printing to shape food in the particular shape you like. Okay, so so before doing that, maybe start here. Okay, so this is the okay. So here's the our university, Singapore University of Technology and Design. And if you are interested, I think this is a relatively new university in Singapore, which is actually one of the most recent engineering university in Singapore. We do have a few, the research program as well as the the department as well. So the department and the research center I belong to is so-called D&D, Digital Manufacturing and Design Center. This is a research center to focus on basically 3D printing. Different aspects of 3D printing, but this is the we do have research is going on in terms of the computational design as well as the actual fabrication using 3D printer as well. we also have, our university was originally established with MIT in the United States, and then we do have this research center called IDC. This is called International Design Center. Here is the one. At this center, I have been involved in this project of 3D printing of food. So please, if you are keen, please have a look at our university, and then we are actively looking for the international applicants for the university as well. So this is a little bit about myself. So my research interest is essentially anything that involves the food and soft materials. I am interested. So one of the major research themes is so-called microfluidics. This is the microfluidics is basically a technology to handle relatively small amount of the fluid in the micro scale features. So this is using this often we perform we try to make for example portable diagnostic devices as well as the structures that looks like physiological structure such as organ. So this is the one of the research fields of microfluidics, and then our group is actively studying. In addition, we are interested in the soft materials and such. You may see the flexible devices, wearable devices are recent trend in terms of the biosensing and such. And then our group is also actively looking for that kind of research. Lastly, the digital fabrication. This is the one of the big theme of our university as well. But the idea is using this 3D printing technology to make different type of materials, designs, structures, as well as devices. So as one of the research topics under this category, digital fabrication, we are working on the 3D printing of the liquid materials. So and then this is actually leading to the today's talk about food printing. So you may see, this is some fancy picture of the food. Okay, this is just just a quick, just a little extra information, but this is my family's business actually. My family, my father, and then my the brothers are doing this kind of business to make candies and sweets in Japan. Then this is the where I come from. They are not researcher, but we have a lot of things in common. So just okay, let's talk about a little bit about the research background here. Okay, so I think moving. Okay, so these are the movies that is taken from the 3D printer manufacturer. Okay, so this is the technology we are using. So-called this is called so-called additive manufacturing or 3D printing. So the additive manufacturing refers to the group of technologies or techniques that involves the automated fabrication of the structure, starting from the digitally designed the drawing. Okay, so there are a few different type of 3D printing technologies, including one of the very famous one is so-called FDM, which is called fused deposition modeling. As well as the here is the stereolithography. This is based on the 3D printing based on the photocurable resin, as well as the polymer jetting. This is more like an inkjet technique to print the 3D structure layer by layer by using the nozzles, inkjetting nozzles. Okay, so each technology has different focus, different pros and cons. But today, the technology we are using here is so-called, this is so-called, the direct ink writing, extrusion-based 3D printing. So before going into the method, let's go first with the materials. Okay, so the materials, as you may know, okay, so this technology is so-called extrusion-based 3D printing, meaning you have a nozzle and then you place the materials, and then by putting the pressure, material is extruded from the nozzle. So there has been a demonstration of the printing, for example, chocolate or cheese or different type of potatoes or doughs, bread dough, for example. I mean, so there are many different applications. I mean, also vegetables, puree. Okay, so why 3D printing? 3D printing allows us to make a structure of the food in a very unique way. For example, top left is type of structures that will be a bit difficult to create if you are trying to this kind of stuff. In addition, I mean you can also create the different type of internal structure, which is if you take a look at the bottom left example. This chocolate has been 3D printed, and within the chocolate, there are different density of the material is printed, which is going to control the texture. So this is one of some of the things people have been doing for the 3D food printing. Okay, let's come back to the method, right? Okay, in terms of the methodology, 3D printing has been broadly grouped into the two type of method. Okay, one method is so-called powder-based. Okay, powder-based start from this technology is based on the process so-called sintering. Idea is that you start with the powder materials, and then using the laser, and that laser is locally heating the material itself or the binder material, which is going to fuse the material together and then allowing them to create 3D structures. So that is one type of 3D printing. On the other hand, extrusion-based is yet another type of process. And the extrusion-based printing is grouped into two different methods. One is so-called hot melt extrusion. Another one is so-called cold extrusion. Okay. So hot melt extrusion refers to the technique of the basically idea is to heat up the material, and then heated material is going to solidify at the lower temperature. Right. So using this process, okay, while it's being at the elevated temperature, things can flow, and then they are extruded. That is based. I mean, that idea is the so-called hot melt extrusion. On the other hand, cold extrusion is the using the extrusion based process, but you don't use the temperature control process. The idea is you just use the rheological property of the ink. Okay, so the rheological property of the ink means the basically fluid mechanics of the ink, a fluid property of the ink. So everything is a fluid. I mean, you can see any food material is fluid, right? And then not sure if the audience is a university student. I mean, you may have studied different type of rheological property of the edible materials. Okay, so you can I mean, for example, different inks property such as shear thinning or shear thickening you may have heard of. This kind of different type of property. Some property is required to achieve the extrusion-based 3D printing of the material. Okay, so I can probably describe a little bit more about that. So why, I mean, before going into the technology itself, why do you want to do the cold extrusion? So cold extrusion is a process you can just use the ink itself without doing any temperature control. And this is really the convenient because otherwise, if you want to print something, if you want to print a chocolate, for example, by using the heating, right? Then you have to have a temperature controller, and you have to heat it up, and you have to cool it down. Okay, so this kind of process is the doable. However, this is a bit cumbersome. Okay? And then on the other hand, cold extrusion is you can just use the native materials property of the food itself. So that allows us just push materials at the lower temperature or room temperature, and then you can easily achieve the particular shape. So in that sense, this is a bit more user friendly. It is easier to control the process. Then on the other hand, if we add one more advantage, this kind of cold extrusion process is more suitable for the heat-sensitive nutrients. Meaning, some nutrients would be destroyed at the higher temperature. So there is a need to print materials at the room temperature without changing too much, without damaging them. Okay. So, so here is the process. Okay, this is 3D printing of the liquid materials. And then we use this 3D printer called direct ink writing 3D printer. Then this picture, okay, this picture is the actual 3D printer that we use in the laboratory. Okay, so the idea is you can see some of the syringe holder. You can put your syringe, which is filled with the solution or slurry of the materials that you want to print. And then you put the pressure on the back side of the syringe, and that is going to let the materials come out from the nozzle. And then on the other hand, this nozzle is attached to the robot. And then this is this robot gives you control of the movement of the XYZ direction. And this is this lets you to create this lets you to create the structure that you like to create. Okay, so what is really the matter, right? What really matters? If you want to perform the direct ink writing 3D printing, one of the major things you have to think about is sort of printability. Okay, so printability means is the material able to be printed? This is the printability, right? Okay, so the or to ensure the printability, you have to have a materials properties. So first property you need is when you push the materials, it must go through the nozzle. Okay. To do that, you can imagine if the material is too viscous. If the material is too viscous, it is difficult to extrude. Otherwise, you really need a high pressure, which may not be feasible concerning the limitation of the instrument. Okay, so that's one of the properties. You must have an adequate viscosity. At the same time, while it's being printed, it must flow, and then after it's being printed, it must remain the structure. This is a difficult part, right? If you think about the fluids such as water, right? After you print water usually spread at the surface. Okay, so this is suggesting water is not 3D printable. Water can be pushed out of the nozzle. However, after it is being printed, they are going to spread very easily, right? So this is not, the 3D printable. Okay, so the ideal materials, okay, for the food 3D printing or direct ink writing 3D printing must have two properties. One property is so-called shear thinning behavior, and then another property is so-called yield stress fluid. Okay, let me explain one by one. Okay, so first of all, shear thinning behavior is something like when fluid is moving. Okay, when fluid is moving, this viscosity goes down. This is the particular property called shear thinning behavior. By applying the shear, fluid becomes thinner. Okay, so this is easier to flow. So this is where name is. So to have this shear thinning behavior, this is the master. At the same time, you also have to have the property so-called yield stress fluid property. What does that mean? So this means after you print, you have to after you print on the substrate, this fluid must have a more like a solid like character. So this yield stress fluid is the to ensure after the material is being printed, you want to avoid the spreading of the materials. Okay, then to form the self-supporting layers to maintain the structure. Okay, so these are the two major properties that we have to achieve. Okay, so how can we achieve such a property? Okay, so now this is one of the inspiration we can get. Okay, so I know many of you brush your teeth, right? For teeth. Okay, so the toothbrushing, you can think about the toothpaste. Toothpaste, I don't know if you have noticed or not. This toothpaste has a really unique property. right? Is toothpaste solid or liquid? In a sense, this is sort of in between, right? After you put your toothpaste onto your toothbrush, it does not spread. However, when you are putting the pressure from your tubing, right? When you are pushing your toothpaste out of your tubing, it is actually flowing, right? So this is, in fact, suggesting, okay, this is actually the two properties I just mentioned. So shear shrinking property is when you are applying the pressure, when the this paste itself is flowing, right? Then it flows. This is the one way. And then another way, another required property is the after it's being printed on somewhere, they maintain its shape by the yield stress. Okay, so this is the another property they need. Okay, so this is quite a nice property. So now the objective here is, okay, can you have your food? Can you make your food possess such a properties? And then indeed it is possible. Okay, so this is the one of the things we did in the lab. So we are printing this shape. We are basically printing chocolate. Okay, we are printing chocolate, and this is not just a chocolate, but this is the chocolate, the liquid materials containing chocolate, and we call this the chocolate ink. Okay, so this is on the left hand side. This is intentionally showing the bad results. Okay, so we are using this chocolate ink as purchased. I mean, this is quite tasty if you put it on your bread, right? I mean, then it must be very nice. But after you print this, okay, it's immediately spread, and then they cannot maintain the printed structure here. Okay, so this is the so-called rheologically unmodified ink. Unfortunately, with this ink, you can make a 3D structure. Okay. On the other hand, after we do a bit of a trick, okay, this is by adding the some edible materials to the chocolate, we are able to, you can see there is an ink, right? There has been ink is being printed. And then after it's being printed, you can see the printed structure is maintained without spreading. Okay, this is because of the yield stress property. Okay, the yield stress property meaning the materials after being pushed does not have to be spread, and then so this is quite nice property. Okay, then I'm going to make it a bit faster. Okay, by moving. Okay, you can put with this, right? You can put the materials on the top of materials, meaning you can make a multiple layers, right? Okay, so this is the really suggesting this ink is the 3D printable. So I hope by this I convinced you by choosing the appropriate rheological property, which is a material property. You can make the structure into 3D. Okay, so here's the actual some of the actual research. Okay, so in fact, okay, this is the chocolate ink printing. This research is led by the Dr. Kayapa. So we in this research we formulated the chocolate ink so that it is going to possess the appropriate rheological properties. Okay, this 1, 2, 3 means they have 3 stages. Okay, one is the when the fluid is in the syringe. You need a particular the pressure to be extruded. And then while this is okay within the small range of the tool, within the nozzle, their viscosity goes down because of the shear thinning property. And then once after you print it back, they go back to the same viscosity to maintain its structures. Then we made a bit of the characterization of the materials. Okay, and then we started the 2 different type of chocolate ink, which is the chocolate ink, we call this chocolate syrup and the chocolate paste. And then we added by adding the chocolate powder in it, we control the rheological property of the ink. And then this actually permitted us to achieve the shear ink as well as the some ink that possesses the yield stress fluid properties, as shown in the B here. Okay. And then here is more like visual result here. If you take a look at we try to print the mesh, okay, and then from the top to bottom, as you go down, we added the additives to ensure the printability of the ink, right? So when you don't put any additives here, interestingly, chocolate cannot be printed. After you print it, spread immediately. But as you keep adding the materials, it can maintain the print structure. Okay, and then after that, okay, if you take a look at on the right hand side, not just a mesh structure, you can make a really different type of different kind of the 3D printed structure here like this. Okay, so here's yet another result. Okay, we can also do the same thing with the milk product. In this case, what we did here is we use the powder milk. Okay, and then the powder milk, as you can know, I mean, if your parents sometimes you use powder milk to feed the kids, the children, we can put a different amount of powder to formulate milk. And then what we studied here is when we increase the concentration of the milk powder quite high, right? You can indeed you are able to make a 3D printable milk structure. And then interestingly, I mean, similar characteristics. Okay, in this particular case, okay, depending on the amount of the powder, milk powders, you can actually make the ink of the yield stress fluid, and then it is actually possible to maintain the print structure as well. Okay, so this allows us to create different 3D structures as such. Okay, so indeed, this kind of technique can be combined by using different nozzles. So you can make the 3D printers 3D printed structures that involves both chocolate and the milk, as well as more than 2 materials by using multiple nozzles, right? You can also perform the enclosure of the materials inside of the materials. Okay, so yeah, maybe this is a video that shows how this 3D printing look like. This is a rather first video. So this is how we can structure by putting materials layer by layer by extrusion. This is something that's going on. This is the 2 materials. You put, in this case, orange material is some kind of orange-based materials, and then you can also put layer by layer orange and chocolate all together. And then, I mean, this is coming back to the other original structures that has the different shapes. Yeah, so okay, so here's the ongoing result here, but anyway, so I hope I have convinced you it is actually possible to shape the structure of the food by using the 3D printer. Okay, so for the rest of the time, I briefly talk about a little bit of different technologies, more like engineering technologies that may be useful for the food printing. This is the ongoing research that we are doing here. So one of the technology we are using is so-called microfluidic technology. Okay. So microfluidic technology, as you can see, currently, our demonstration is typically uses 1 materials at one time. But perhaps we can design the nozzle better. We are able to achieve the more interesting structure here. Right? So the microfluidics, if you have seen, this is a technology that has been developed over the last 20 years. This technology allows us, for example, to create emulsions, bubbles, droplet emulsions. And then you can see, in food, as you can see, there are many, multi-order emulsions found in food, such as mayonnaise and whipped cream. These are the structures that is sort of ubiquitous in the food. So something we did is this is ongoing research. We have created a nozzle that allows us to create the different type of emulsion. Okay, so emulsions inside of emulsion. So as you can see, so this is a 3D printed nozzle that can be attached to the 3D printer. And with this, right, as you can see, you can make a simple emulsion, which is a very simple emulsion, which is shown in the bottom left. This is the single type of droplet. Then, not that, but if you arrange these, nozzles in the serial way, which means back to back, you can make a more complex emulsion. For example, emulsions inside of other emulsions. And if you sort of do it very carefully, you can also create the emulsion that has the two materials inside. So we are currently trying to push this technology to realize a more complex food structure. So what's next in the 3D food printing? Okay, so this is more like open question that many of you may have opinion. Now we have a technology, right? What can we do from here? So here's a few different research directions that we are working on, as well as the many other research groups are working on in the world, right? Okay, so 3D food printing. First things people are doing is obviously the integration of microfluidic technology, which allows us fabricating the more complex structures, as well as can we do this, for example, texture design, meaning some of the work already touched the concept, but one of the really unique thing about 3D food printing is you can design the texture of the materials. So you don't need to create an entirely filled structure, right? If you create a mesh structure, you are able to sort of change the texture design. Okay. Other things people are looking is more like a personalization of the food. Okay, so this 3D food printing is very unique in terms of you can make each dishes one by one with the customized design and the materials. Okay. So, one of the ongoing research here is so-called, the hospital food for the people with dysphagia. Meaning, there are, some kind of, the symptoms. People has a difficulty in the swallowing materials. Okay. So for such a cases, the hospital patients need the food with the customized texture. Some research groups, including our collaborators, are looking at the food that can be 3D printed food that has the customized texture to address this problem. Okay. Yet other things people are looking is this sustainability. Okay. So sustainability has been really a big issue of it's providing the food, for example, right? So many researchers are currently looking for the alternative protein source. For example, right? The people start looking at the insect-based food, or the food that is discarded, but really high in the nutritional content, right? So for those food, can we actually use them to make them into the reasonable food shape? Can 3D printing contribute to that kind of technology? This is the also one other type of things people are looking into. Okay? And then, lastly, this is a bit broad concept, but the digital gastronomy. This is, in a sense, this is one of the frontier. This is one of the, it's being conceptually simple, but the not being used in practice much. But, can we really integrate the food production or, personalization, personal food production with the 3D printing? So we may have some future, right? Something that in the future, okay, each household owns the 3D printer in your kitchen, and then instead of cooking, things you are able to use 3D printer to serve your own breakfast. This might be possible along the way. Okay. So these are the possible topics of the that might be even explored in the future. But this is I'm sure all the audience here is the young students, right? And then for the young students, this is actually left to you. You are the one who can think about how to use this kind of technology that might be more relevant, more useful for your own application, right? For your own objective and applications. Okay, so that's the last part. But anyway, yeah. Here's the our team, and then I'm showing everybody who has been involved in this work. This is actually ongoing work. We are still working on the trying to extend the capability of 3D printing in terms of the materials and then the instrumentations and everything. Okay, so this is something we have been working on, and then we also sent the collaborator. So I think that's all for all I have today. So thank you very much for your attention. I'm happy to take any question you may have. Okay.
Thank you for very interesting talk, Prof. Hashimoto. So I believe that we have some questions already from the participants. Okay, so now it's open for questions and comments if you have. Please raise up your questions directly to Prof. Hashimoto, or you can also put it in the chat room for me to convey to him.
Yeah, I can also chat directly.
Yeah, you can also ask directly. Eh? Anyone? Okay. All right. While waiting for anyone who would like to ask directly, Prof, I got questions from the chat here to me privately about the costing. If the product is developed through the 3D printing technology here, like the one chocolate and milk, will it affect how much the cost will be increased by incorporations of this technology?
I think so in fact, the 3D printer itself is not that expensive. For example, right? So if it's a mass production, right? Of course, you have to have a different type of production instruments and then machines, right? So in that sense, if it's an industrial production, I don't think it's much. But in any case, 3D printer itself is now getting more and more affordable. Of course, this is not yet free, but for example, with this kind of 3D printer I introduced, I think we are able to develop a very simple printer, probably at the cost of maybe the 300. Even now, right? This is available. You can make it on your own. With a few $100 US per printer. Okay, so this is not again cheap, but considering like 10 years ago when this technology, all this is protected by patent, right? This has been quite expensive, but nowadays the instrument is getting more and more available, and then in the future, down the road, I am pretty certain that technology is going to be more affordable. Then so the main cost is this 3D printing is just a method to shape the food, right? So in a sense, running cost is just a food material, right? This is not something you may have to change the the printer device, and then sometimes the wash it to these things. But I would say this is the relatively the marginal. The main part of the cost is the main part of the running cost is the field material itself. So I don't think if the instrument is available, I don't think it's going to be any limiting factor.
Okay, thank you, Prof. And then, okay, before I go to the second questions, anyone would like to ask directly? Let me call, please. Sumiati, you have questions? Hermione, are you okay?
Okay. Good afternoon.
Yeah, please.
This is Mohammad Murshid Hassan Mustafa from Bangladesh.
Okay, please.
Thank you very much for your nice presentation, Professor Sir, Dr. Michiano Hashimoto. I have enjoyed the presentation from the very beginning to that time. Today's event is interesting. For these topics, I think I have only one question. It's a engineering term, so many engineering terms. We are the biological student. So I think it's a biomedical engineering term. Just I want to know if you use this technology, it's a hygienic for human health or children. Have any documentation reference from IST by ISO by international standard?
Oh, okay. For the, you mean yes. For the international standard of
ISO, GSP, and any other
engineering standard. So that's really a good question. So at this point, at this point, to the best of my knowledge, there is no international standard of the 3D food printing. It's not standardized, but now we are trying to work together with the different the researchers and the industry in Singapore, trying to make that happen. Without the standards, it's very difficult to bring this kind of technology for the industry use. So yes. At this point, there's not standard established.
Thank you very much.
Okay, thank you, MD Murshid from Bangladesh. Anyone else? I saw someone would like to ask. Franz Gidio, Fitri Yunita Sari, you have questions?
Not yet, sir.
Okay. Albert? Oh, not here? Okay. Okay, Prof. I go first to the second questions. In terms of upscaling, okay, let me read this one. In terms of upscaling, what is the maximum volume can be accommodated in the 3D in the 3D printing as an ink, right? So how much volume can be accommodated to produce to design the product?
How much? Sorry, how much what?
Volume of the ink or something, I think.
Okay, how much volume of the ink? I mean,
yes,
that's a good question. Okay, so at this point, right? At this point, we are doing this is sort of micro projects. I mean, you have to go also go one by one. So we are with the current one syringe is the let's say one syringe is the 20 milliliter of liquid can be printed in the let's say 30 minutes. But this is more like how we arrange the device, right? So for example, if you have more than one syringe, we can simply scale up. If you are talking about the scaling up, it can be achieved by the number of printers. If you have 100 printers, you can actually scale up by the factor of 100. Then also the other things, if you are able to create a nozzle, current nozzle print materials only one by one, right? But if you are able to create a nozzle that allows the multiple printing, this is going to be a factor, right? So So this is there is a yes there is a one nozzle and one printer. There is so much you can print, but I think if we are bringing to the industry, this one of the approach is by designing a nozzle as well as the printer itself to sort of parallelize the multiplex the process to achieve the volume of the printing.
Okay. Okay. Thank you, Prof. Some questions just now come. Estimated cost for 3D printing. I think I already answered. And anyone else?
I have a question, Pak Cahyo. It was a really nice presentation, Professor Hashimoto, and a really interesting for the last slide that you mentioned about the sustainability aspect that you indicated about what is the next stage for this 3D printing. And I was like wondering, because it's not really clear for me, how would you deal with this sustainability aspect? Would you say that this technology can help us in a better way to producing food, or like to help us in providing food in a better way, in a sustainable way? Because, for example, you're reducing the number of the animals on farm, which of course there's also relation with the greenhouse gas emissions released by the animals. Or would you also say this could be also potentially contribute to sustainability in that sense that more efficient on the farm, but on the other hand, I also see probably this technology use a lot of energy, and then of course this also contribute to greenhouse gas emission and climate change. So I was like wondering in which sense and what sense that this technology can contribute to for sustainable food system in the future. Thank you very much.
Thank you very much. This is a very, very nice question. And then, I mean, to be fair, I mean, I don't think there are any single answer to this, right? I mean, this is more like how we want to use this technology. So let me just give one, perhaps two particular scenario. People in the field looking. One is the so-called 3D printing of the artificial meat. So this is people have been really I mean, there has been the ongoing research of the the eating the meat using the cell culture system, which is really reducing the reliance on the animals, right? And then the people are expecting, okay, that is going to reduce all the CO2 and everything. Okay, so in that sense, okay, people are looking at, okay, perhaps 3D printing technology can be used as a printing the such artificial meat structures into the more like edible structure, as well as the trying to create a scaffold to culture such a meat product. So that's some of the the food and the sustainability related research. The interface between the this 3D printing, 3D food printing is sustainability. The second part of the things you are looking is the more like again the upscaling the food, upscaling the food, and this for this part to be fair, again, you don't necessarily have to use the 3D printing itself, but there are many materials, right? Many materials that can be edible, that can be help to provide but that has been wasted. And then one of the attempt, one of the the things people looking are the can we somehow use such a wasted materials by make it into the edible form, or the more like I mean, for example, different different people eat different things. But for example, I think the one of the story in Singapore is to eat. I mean, insect has been sort of proven to be very nutritious, but in many places there is no the idea of directly eating the insect. So can we actually starting from the insect make insect food and then 3D print and then make a structure, and then people can take up the such a food a bit more easily than eating the insect directly. So this is more like in that sense this technology can be used sort of to reshaping the food into the edible form by using the otherwise wasted materials. Yeah, so I gave you these are the two possible scenarios people looking of the applying 3D food printing for in the sustainability aspect. But again, as I said in the beginning, I don't think these are not the limiting answer, right? I mean, not the only two answers. I mean, I think it is. I mean, if you think about any, I mean, if you can ever think about any approaches, any ideas, that can be useful for the sustainability. Yes, people would love it. People would love it. I guess so. If you're interested in this field, yeah, please, let me know. Happy to.
Okay, Windy, is that okay?
Yeah, was really nice. Thank you very much. So we still see there are so many potential ways to deal with the sustainability in the future, I believe. Yeah, thank you very much, Pak Cahyo and Professor Hashimoto.
Thank you very much.
Prof, two last questions. This is very technical. Would you explain why SLS method, the selective laser sintering, is more suitable for the sugar or fat-based product compared to the the other ones?
Okay, let me go back. Yeah, so your question refers to the here, right? Okay. So the selective laser sintering, this method is this is better for the powder-based materials. So the reason here is the mechanism of printing. So first of all, okay, selective laser sintering is you can also put the another technique of the binder jet printing. But these two techniques basically is you have a laser. Okay, this extrusion method is you have a nozzle, and then this nozzle is going to move 3D. In case of laser sintering, you have a laser, and then this laser is going to be focused, and then they can move in the 3D. The idea is when this laser is focused on the one spot, this materials locally is going to either deform or in this case of the sugar printing, perhaps they may have some other kind of binder module, meaning this binder material is the one that is going to be slowly melt locally, and then after you move the laser, they go back to the original temperature, and then they are bound to the surrounding area, right? So this technique it can be used, using the sugar and the binding materials. For example, you are able to perhaps connecting them together, and then making the 3D structure out of powder. So if it's not for the food, people have been using for this technique for nylon. Nylon can be partially melt at the higher temperature. And then after shining the laser, heat it up, and then melt locally, and then if you if you go around the powder of nylon powder at the back, and then if you go around with the laser, you have the molten and fused ring of the nylon, right? The same idea here is you can use the powder-based to do this kind of process.
Okay. Okay. Thank you, Prof. Now I open for the last questions, maybe from the participant. Anyone? Prof. Irma, you have any questions you want to ask, right?
Just a simple question, Pak Cahyo.
Yes, Prof.
Professor Hashimoto, thank you for the nice presentation. I would like to know how to applicate the 3D food printing in the future, especially to protect our food in the pandemic era, and also for the developing and developed country. What is the prospect of the implementation of the 3D food printing?
Yeah, I mean that is really the good question. Yeah, I mean okay. So for this, so first of all, okay. So for the pandemic era parts is the let me give what I mean think this can contribute. Okay, so for the pandemic era, I mean this is the process. This is more like in the end. Okay, we can consider this is more like automation of the food production or food serving. Right. So this is with this the perhaps it might be possible. I mean if the process can be automated, and then you are able to support supply these food materials to start, and then that can be excluded. And then or they somehow process can be fully automated and then directly served to the people who eat. Right? And then with this kind of process, yeah, we are able to remove the variance of the human coming into, and then that is really more preferred. Automated process is really preferred in this pandemic conditions. I mean, so the more like this kind of technology may be useful to do the to achieve this more like the fully automated food production and serving manufacturing. That might be there must be a room that this technology can contribute. Hopefully, that is your first question. Second question, actually, to be fair, I don't know. It's how can this kind of technology can contribute, especially for the developing countries you mentioned. Is it the question? Yeah. So that's actually the okay. So I'll be honest. Yeah. I think at this point this is more like, yeah, I mean this is more like maybe the technology itself is still developing. So it may not I may not have any conclusive direction and such, but yeah, I mean I also want to perhaps I don't do you have any suggestion how this technology can be used in such a context? I think this is a really good question, and then I have to admit I don't have a good answer myself, but with this I mean yes, I mean I also want to be really if I get involved in the developing the technology, I think it'd be very nice if this technology can benefit. I mean, not only I guess more like the developed country, but also developing country. If this technology can benefit, I really think it's a great perspective, great direction. Yeah, I would like to hear if there are any I think any way this can be applied in a more broadly. Yeah, I mean, do you have any suggestion? I mean, this was more like sorry, I don't have any conclusive answer for that.
Okay.
Thank you for your explanation.
Yeah, thank you so much.
Yeah, perhaps the second issue will be that's the challenge of the development of this technology in the future, bro. But yeah, in fact, this is very interesting. Okay, so I think due to the time, unfortunately, I have to close the sessions now. Thank you very much for the comments, questions, and then also, of course, thank you, Prof, again for the presentations and for the sharing of your research, and then also some opinion on the 3D printing technology, particularly for the food products. But before we really close these sessions, I would like to there is some token appreciations for you. And unfortunately, the token is cannot be given physically. we have prepared it in digital form. So certificate of appreciations will be given by who will deliver this token, the certificate?
Aisdin.
Okay. Will be by Prof. Irma Isnavia Arif, Vice Dean of Faculty Animal Science. Perhaps committee can display the certificate. Prof. Irma, please. Your microphone, Prof.
Yeah, okay, wait a minute. Thank you. On behalf of the Faculty of Animal Science, IPB University, we would like to thank Prof. Dr. Misiano Hashimoto. Thank you very much, Prof, for your kindness to deliver the very nice presentation about the 3D footprinting. Thank you very much for your come in our university. Thank you, Prof.
Thank you very much. I hope this was at least I know this is a little bit different from but yeah, has a different technology.
Susah nggak? Kalau saya sini dulu simpan belakang.
Hello, participant, please mute your microphone. All right, okay. Thank you, Prof, for the sharing, and definitely it is even though it's coming from the different field, but it is quite relevant to us because I think in animal science one of focus in the department is how to develop the animal product technology, and then using the 3D printing will be one of options to develop the animal product to be more sustainable and so on. So thank you.
I also mean if any of the students as well as the faculty members, this kind of technology might be interesting. For your research or for your the development, please feel free to contact me. We can also discuss further. As I mentioned, this is I really mean it. I don't want this just to be a technology for technology, right? I want this to be technology for really making difference, right? So please do let me know. There's many perspectives I know I'm limited to, right? So if this technology can be used for your own field, I think that'll be great. So please do, don't hesitate. Let me know if you have any good idea of how to use this technology.
Okay, that's great. That's very interesting. So I think it's open to everyone. If whenever you have idea, or if you have more, would like to develop this technology for, let's say, develop milk or meat and so on. So you can freely contact Prof. Hashimoto for further studies, collaborations, and so on. So I do believe that this will not end our relations here, Prof. I believe that we have further communications and collaborations in the future. So
right.
By this,
yeah, the Singapore is very close by, right?
Yes. Less than 1 hour flight, Prof.
Next time I don't buy.
Hopefully the pandemic will over soon, so that the travel will be open soon, and then will be no issue for us to do mobility from Indonesia to Singapore and vice versa. All right, okay. So everyone, by this, I would like to close this session. Thank you again for Prof. Hashimoto. So thank you for all the participants. By this, the session is adjourned. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Back to MC, Indy. Thank you, Prof. Thank you, everyone.
See you later.
Thank you, Professor Hashimoto, and also Pak Cahyo for nice talk and also very inspiring lecture today. And yeah, so we are moving for the next section, in which we will have the virtual expo. Yeah, this is also quite interesting because in this pandemic situation that we still want to deliver our work, and we still want to have the expo, so it's kind of virtual expo. So the idea is we actually already have the poster, also the photographs which coming from participants during last 2 weeks summer course, and then they have to deliver their tasks, and including the posters and then the photos. So we will show it right now, and then actually we kindly request all the participants to vote which do you think it is your favorite, of course. So in the chat box, the committee will share the voting, the link for voting, and so you can choose one of your favorite for the one photos, and then one photo and one poster. So I believe that it's there now. Yes, so you can click this link, and then I will show you the nomination for the photograph, so I can guide you a bit. But actually, you can see also in the link that there's kind of different photographs there. But I can guide you through the photograph one by one. So here is the nomination for the photography from the summer course program. So the first is group 1. It's coming from Bangladesh. It's okay, sorry. Before that, I would like to acknowledge this is the original pictures from participants. So it's not from the internet, it's not from Google, but this is coming from originally from their own country. So this is really interesting. So we can see the original situation in each country, I believe. So the first group is coming from Bangladesh, and this shows the milk processing unit at Safar Dairy Farm. So it has the milk transportation, milk buckets cleaning, milk processing machine, milk packaging, and how they are package their milk. And this is also the cold storage. So it's all about how milk processing is going on in Bangladesh. And then next. Well, I think this is also quite interesting. This coming also from Bangladesh. It is called Draft Cow of Bangladesh, or they call it Rani. Rani is also Indonesian name actually, but this is very cute. This is the draft cow of Bangladesh, which was found in Karigram, Nebignagar, if I spell it correctly. It's part of the Bangladesh area, I think. And this is the drawis in cattle, which has the condition that's created when the calf receive gain mutation from one or both parents. So it was really small, I think. It just like it's 2 years old runny, and it's 51 centimeter long, and it has 26 kilogram body weight. So it is the smallest cow in the world according to the Guinness Book of World Records. And yeah, so this is also the original picture from the students from Bangladesh. Next. So yeah, because we also so the participant also have to deal with the related themes from this summer course program, and this is also related with the pandemic situations. So this is the collaborations group from Philippines, Thailand, Malaysia, and Bangladesh, in which they are showing the working activity during the pandemic situation, in which the butcher they have to use mask during this working activity. Food safety and security is a very important, of course, during this pandemic situation. So this is kind of the butcher mark in Malaysia, probably. Yes. Next. And this is coming from Taiwan, in which they are showing the chicken in their laboratory. It is called Chung Hasing Red Feather Native Chicken. It's native chicken, also probably from Taiwan. It was found in 1982. And it's very unique because it was bred by the Taiwanese professor, and then in the third grade generation they are going to raise their own chicken, which through its whole living period. And under the COVID-19 pandemic situation, there isn't any change to the chicken, which is very good according to them, of course. But for feeder, they need to sign the signature before entering the co-op to ensure the safety and the caretakers, and also for the chicken. So this is kind of the situations in Taiwan right now. And next. Yeah, this is from Indonesia. It calls Bayu Cattle, and it stands from Bali and Wagyu cattle. So it's a combination of from Bali cattle and the Wagyu cattle, and it was bred in the inseminations research center in Semarang, Central Java. So this is a kind of breeding cattle, Bayu cattle it called. Next. Yeah, this is also still same from Indonesia. I think it's the same, but I don't know if this is a breeding cattle or not. But this is also kind of typical beef cattle that we can find easily in Indonesia. So next. Yeah, I think last 2 weeks we had the sacrification days in which we sacrificed the animals like cattle or goat to God. It's kind of the Islamic celebrations, and this is kind of also the situations of the Idul Adha, we call it in Indonesia. So we in these traditions, it is involved the slaughtering and the animals, and then the sharing the meat to the neighborhoods in order they can also enjoy the meat during this Idul Adha festive. And the title of this picture is Meat for Everyone. So this is also very nice. Yeah, so the goal of this the goal of this celebration is to make sure that every Muslim gets to eat meat, and the celebrations has a clear message of devotions, kindness, and equality. So next. Okay, this is also from Indonesia. This is a swamp buffalo. The swamp buffalo is one of the genetic source livestock found almost all around in Indonesia, and the livestock are rare as a meat and milk producer. And worker livestock are generally maintaining the traditional system. And yeah, so buffalo livestock system is a quite important in providing social economic contribution for farmers in Indonesia. Next, so yeah, there's also promotion. Thank you for selecting a player group 2, Bangladesh. Okay, nice promotion. Okay, and then the next also coming from Indonesia. It's a strip buffalo. It's also kind of another buffalo type. It's Tedonga. It's called Tedong Bonga. It's an endemic species of a mud buffalo in Tanah Toraja in Sulawesi, and it used mostly in a traditional funeral ceremony. And the male strip buffalo is used as an over for the Torajan people. Then there is also belief that the better strip of buffalo, the more slaughter and the more expensive, and then the better and the saver of life of the decrease in the afterlife. So it's also really interesting from Sulawesi Island. Next. Yeah, because we are now kind of we have a very strict situation in the pandemic, and then this photo shows a freedom in new normal situations. So it's from Indonesia as well, in which sapi pesisir it called. And it is a breed of the cattle found in West Sumatra, Indonesia. And since in the normal period, everyone spends more time at home and limits activities outside the home, and it has an impact on the cattle life, which make them very difficult to get feed from the farmer. So the cattle are released into the wild and let them to feed themselves. So this is now quite common in Indonesia, which, yeah, of course, it's really difficult for the farmers with kind of these restrictions to feed the animals. And then this showing this nice picture and also a nice angle to take a photograph showing that it's kind of freedom in these new normal situations. Next. Yeah, this is also from Indonesia. It is more or less the same during the Idul Adha festive. This was taken before the cow got slaughtered in order to do God's command. And yeah, the idea is the same with the previous that I told you before. It's to serve the God's command that honors the willingness of the Ibrahim prophet to sacrifice his son Ismail as an act of God's command. And during this festival, families can who can afford that they sacrifice the animals and then divide the meat and the flesh equally among themselves, so the people can enjoy meat and at the day of the Idul Adha. Yes, and this is it is also coming from Indonesia. It's called Jawarandu goat. It's a goat from where is that? Blingon, Gambolo, Koplo, and Kacukan. Yeah, I don't know where is that, but this is from Indonesia. And then the goat is the result of the crossbreed of from the Etawa crossbreed and the Kacang goat. So this is also from very native from Indonesia. And then the physical characteristic of the Kacang goat are more dominant. And to save, usually goat milk breeders choose this goat to raise for milk. Okay, so this is for milk purposes. And then this goat can produce 1.5 liters of milk per day. Okay, and this is still from Indonesia. And then this is the Etawa and Javanese Randu breeds are one of the types of goats that exist in Indonesia. And in this goat, the goat is one of the meat goat that is widely used as a sacrifice the animal, like in Idul Adha. We use this goat. And then this picture shows the type of Etawa and Javanese Randu goats that are waiting for the time to be slaughtered during Idul Adha festive. And yeah, this is from Indonesia still. And then this is the Bali cattle, which are domesticated cattle from the bull animals in Bali Island. This cow has a characteristic that it has colors on the legs and buttocks with white and a brown body. So the Bali cattle also have long horns that point upward, and in contrast to most cows. And Bali cattle are chosen to be to be used in Bali, most of them, because it has a very good economic price and it has large populations. And during this pandemic situation, the daily consumption of beef quite decreased, but the demand for Bali cattle for Idul Adha and Idul Fitri remain high. So yeah. And for the last one, it is also from Indonesia. This is showing the environmental animal in a chicken farm. So the environment of the animal in the chicken farm must be accordance with the animal welfare aspect, which consists of the maintenance system, environmental temperature, human resources management, and the function of supervisions of the chicken co-op. And paying attention to the animal welfare aspect in the animal environment around the farm, it can make chicken have good quality. Yeah, so that's all. Oh, sorry, there's another one. Okay, this is also from Indonesia. Handling kurban meat during what is that? I cannot really see clearly, but this is also in Bali. From Bali, they are handling the kurban meat. It's also for Idul Adha.